Hey guys, I'm recording this for the ionic and covalent bonding notes. The ones I did for class kind of were a little fuzzy and had too many dead spots. So I'm going to go ahead and record this. This is for the chemical bonding, ionic covalent bonding notes. So this is me going through it. If you need assistance in doing this and you want to go through it on your own, there is a link attached to the ionic covalent bonding notes assignment on Schoology where you can follow along with me. So if you want to do that, I suggest doing it. It'll be pretty helpful. So I'm going to run through this pretty quick. If you are filling out the notes along with me, make sure you pause this when you need to fill something in because I won't be stopping and waiting for people to fill in things because on YouTube you can pause it, and continue the notes on your own pace. So here we go. Chemical bonding. Chemical bonding is when two or more elements get together and form what are called compounds. We'll get into that later. And you're building on the information that you learned in the last unit of the periodic table and the atoms by how to identify what atom is which, what element they are, what electrons and protons are, and how the octet rule functions. So by the end of this, you'll be able to identify ionic and covalent bonds and metallic bonds as well. Right? So a chemical bond is the force of attraction that holds two or more elements together. These bonds form through the interaction of the valence electrons. So in your notes, the first two, force of attraction, those are the first two bold words that you should be filling in. If you're following along with your notes, make sure you're filling in the blanks when they appear on the slides. So that's what a chemical bond is. And like I told you guys earlier, chemical bonds happen with the valence electrons. So the valence electrons are what give bonds their special nature. So these electrons either give or gain valence electrons in order to get their octet rule filled. So for example, an atoms tend to gain or lose electrons to have 8 valence electrons. Carbon would gain 4 electrons because it has 4 valence electrons here. 1, 2, 3, 4. And then it would gain 1, 2, 3, 4 more to make 8. In nitrogen, over here, the outer ring are the valence electrons. The blue ones that are filled in are the ones that it has, and then the empty spaces are where it will gain electrons. So the octet rule means that they have 8 valence electrons in their outer shell. So 8 would go in the blank. So the first type of bonds we're going to be talking about are ionic bonds. Ionic bonds form between metals and nonmetals. That's key. Metal and nonmetal. These electrons are transferred from one to the next. So where it's completely moved from one atom to the next atom. These form like a crystal pattern structure. So if you look at the picture on the right here, you have an ionic bond. Sodium is a metal, chlorine is a nonmetal. This forms sodium chloride, which is table salt. It's what you eat on your food. And it makes this cool crystal pattern when they bond together. So you're going to be looking at this periodic table on your notes next. And I'm going to go through and show you how to do it. So before I do that, I want to make sure you understand where the metals are and where the nonmetals are. So metals are going to be in blue, and nonmetals are going to be in red. So if you look closely at the periodic table, I'm guaranteeing that you've heard of things like titanium, iron, cobalt, nickel, copper, zinc, silver, gold. Where's another one? You probably heard of platinum before. Chrome. These are all metals you've heard of before. I know you've heard of calcium, sodium we just talked about. These are all metals. So the majority of the periodic table is a metal. So here is aluminum. So this red staircase looking shape I have on the periodic table, everything to the left is a metal. So I'm going to do a very bad job of coloring this in to show you that these are all metals. The only exception is hydrogen. Hydrogen is a non-metal. It's kind of sneaky. It hides out over here. And it's up there because it has one proton and one electron in the first energy level, which classifies it on the left side of the periodic table. Other than that, all the ones over here. All right, these are all non-metals. So when a non-metal bonds with a metal, you have an ionic bond. When two non-metals bond, you have a covalent bond, which we're going to get to in a second. So on your notes, let me switch over to there. You should have this periodic table, and here's what I want you to do. So if you're stuck on this part, watch this section of the video. Double click on it. You'll see the periodic table come up. I want you to make a text box over top of the metals. So I'm going to click on the text box here. I'm going to click and drag and kind of just make it go over top of the metals like that. What you should do is you should make your font pretty large. Let's go with 60. And you're going to type in metal. Like that. I'm going to make mine align nice and to the middle. And then you're going to click on the fill color, which is the paint can, and you're going to select blue. So one more time, click on the text, click and drag to make a text box like that. Then start typing metal in it and place it over the metal. So you're going to do the same thing for the non-metals. So to the right of this red staircase, you're going to click and drag and make a box. Make sure the color is red for non-metals, and you're going to type in non-metals over here. This is important so that when I ask you later if it's a metal or a non-metal, you know. And most of them are pretty easy to understand, like oxygen and nitrogen. Like, come on, those are non-metals. If you breathe in, you're breathing those two gases. You know it's not a metal. All right, hit save and close, and you're done. All right, so back to the notes. All right, so here is where it transfers from one to another, and then this is an example of an ionic bond as well. So this right here would come over and get placed on this chlorine. I would make this positive and this negative, and then that would make an attraction between the two. Covalent bonds are the second type. Covalent bonds are formed when two nonmetals get together. When there are two nonmetals, that creates a covalent bond. So any two nonmetals that get together, oxygen, hydrogen, nitrogen, carbon, those make covalent bonds. Here they are shared between the two. So this electron would float on the left side and then the right side and kind of go back and forth between the two nucleuses so that it would be sometimes over the right side and sometimes over the left side. So covalent bonds share electrons. Sometimes they're shared more evenly than others. So for example, if you have two chlorines that bond together, since they're the same atom, they're going to want that electron the same amount, so it's going to spend equal time between the two. But with like hydrogen and chlorine, chlorine wants the electron a lot more, and it's a bigger atom, so it's going to spend more time coming around chlorine than it will around hydrogen, and that's makes it a polar bond. But we're not going to get into that too much. So in ionic bonds, electrons are transferred from one metal atom to a non-metal. Covalent bonds form when electrons are shared between two non-metal atoms. So for this, what I want you to do is, this is going to be on your notes as well. I want you to highlight metals in blue, and I want you to highlight non-metals in red. So you highlight them by clicking the highlighter tool at the bottom. It's the second one. And selecting a color, and then I like to make mine larger so it's easier to highlight. So sodium, if you're looking at the periodic table, is on the left-hand side. So sodium is a metal. Chlorine is on the right side. It's a non-metal. So if you look at your periodic table, sodium is over here, number 11. That's on the metal side. Chlorine is over on the right side here, right here, number 17. So that makes it a non-metal. Metal, non-metal, ionic bond. All right, so hydrogen and oxygen. Hydrogen is a non-metal, and so is oxygen. Magnesium is on the left side of the table. Oops, wrong button. So that makes it a metal. Bromine is on the right side of the table. That makes it a non-metal. And bromine can also bond with itself to make two non-metals there. So go back through and identify these. So if you have a metal and a non-metal, that makes an ionic bond. So on your notes, what you should be doing is filling that in down here. All right, when two nonmetals get together, that makes a covalent bond. You have a metal and nonmetal again, that makes an ionic bond. And two bromines are two nonmetals, so that makes a covalent bond. All right, so here's a quick summary. Ionic bonds change and exchange electrons between the two. And they form between metals and a nonmetal. Covalent bonds share the electrons back and forth, and they're only formed when nonmetals bond with each other. The last type of bond we're going to get into is a metallic bond. So we've covered nonmetals bonding with metals. We've covered nonmetals bonding with nonmetals. So now we got to do metals with metals, and that's a metallic bond. So metallic elements are just elements that are metals. That's all that metallic word means. It's a force of attraction between the positively charged ions and the electrons in the metal. These valence electrons flow back and forth like a combined cloud of electrons. They kind of like make a sea of electrons back and forth. So the electrons just kind of wash back and forth between the atoms. That makes them really good conductors because the electrons can easily transfer energy from one atom to another, which is how heat works, which we'll get to in several months. They're shiny. They have high melting points, which means it takes a large temperature, a high temperature to melt them. And they are bendable. That's what a metallic bond is in general. Here's that sea of electrons I was talking about. So you have all the red electrons, and they just kind of float back and forth between the gray nucleuses. So normally when these bond, they make alloys. So when you make metallic bonds, you form an alloy. So an alloy is when you can melt down two different metals and mix them together. This is a very common practice with a lot of metals we have, because oftentimes the pure metal itself is just plain expensive. So companies will make these alloys to save costs. So there might be a mixture of expensive metal with a cheap metal to make it like kind of almost cut the metal itself to make it last longer. Some alloys have really strong properties, and it can really enhance the metal itself. For example, steel. Iron itself melts and is bendy, but when you mix it with carbon, it becomes stronger in steel. So these are names you may have heard of before: brass, bronze, pewter, and steel. These are all things that aren't on the periodic table, but because they are alloys, they are mixtures. So bullets are made of brass because copper is a dense metal and it's solid, and zinc is a light metal. So when you mix the two, you can kind of make a cheaper metal that you can use more frequently. Brass is a common one, and so is bronze, both common alloys. Okay. All right. So that takes us to the end of the notes for today. Remember, go back and pause anything that you might need a little bit more time on to write down. Please submit this on Schoology so I can grade it, and that way you have the notes to refer back to later, because the notes will help you answer a lot of the warm-ups and things like that. If you have any questions, make sure you reach out to me on Schoology or email, and I will see you guys next time.